Alright, here we go. These are some practice problems for static electricity. Let's take a look at number 42. The question is, what's going to happen as we manipulate this equation? For part A, we got to think about what happens if QA is doubled. So if we take this over here and we double it, what's going to happen to the force? Well, if you double something in the numerator that's directly related to the force, then the force is also going to be doubled. So for part A, it's going to be times 2 as well. Alright, part B is asking what happens if QA and QB are cut in half. If you take QA and you make it half of what it was before, and you take QB and you make it half of what it was before, these two things are multiplied by each other. So what you're going to end up doing is having the numerator be 1/4 of what it originally was. So then your force is also going to be 1/4 of what it originally was. So for part B, it would be 1/4 of the force. Okay. Part C is saying what would happen if R was tripled? Well, R is squared, and it's also in the denominator. So if you triple it, it would be 9 times what it originally was. But since it's in the denominator, that means the force would be 1/9 of what it originally was. Part E, oops, I went too far. Part E says if QA is tripled, okay, so if this thing is 3 times what it originally was, and R is doubled, what would happen? Well, if QA is tripled, that means the top is going to be 3 times. So let's put a 3 up there. It's going to be 3 times what it was originally. If you double R, that means it's going to be 1/4 of what it originally was. So that means that your force is going to be 3/4 of what it originally was. Number 43. I'm sorry. Let me play this back here. Okay, 43. We have 25 coulombs. We want to know how many electrons. Well, first of all, we've got to know the conversion factor. The conversion factor is written right here. If you forget it, it's in your textbook. You can Google it. It's just a fact. In 1 electron, there are that many coulombs. That's just the way it is. So you got to think back to chemistry. You got to do some unit conversions here, dimensional analysis. If we're starting with 25 coulombs, we want to convert to electrons. How do we do it? Well, what you're converting to goes in the numerator, electrons. What you're converting away from goes in the denominator so that you can cancel it out. So coulombs goes down there. We cross out the coulombs. We have successfully converted to electrons. 44, we want to figure out the force between 2 electrons. Here's our equation for static force. K is always the same thing. It's a constant. And since we have 2 electrons, both of the Q's are going to be the same, and they're just going to be the charge of an electron. If you forget what the charge of an electron is, you can look in the book or you can Google it. It's always the same. We have our radius squared on the bottom. Don't forget to, oh, never mind, this time it's already in meters, that's okay. So we find the force, and how do I know that it's away instead of towards each other? When I say away, I mean they're repelling each other. Well, if you have 2 electrons, they're both negative. Negative and negative pushes away from each other. Here we have a positive charge and a negative charge. So in the back of my mind, I'm already thinking, all right, they're going to be going towards each other. It's a positive and a negative. We're given the charges of each, so we plug in our 2 charges. It turns out they're the same charge in this case, so both of our Q's are going to be the same. The radius is given. Don't forget to convert to meters for the radius. Plug it in. You get your force. Again, it's towards each other because positives and negatives attract. Number 46 is the first time that we see 2 different charges. So don't get scared. Just for your 2 Q's, you put in 2 different numbers instead of the same number. And then this time we don't know the radius, so just leave it as r squared. I'm going to show you how I solve it here. You cross multiply. Let me pause there to show you what I did. I cross multiplied here, so I multiplied the r squared times the 2.4 times 10 squared and set that equal to the other side. I didn't bother writing it out because it takes too long. And then you just divide by divide both sides by 2.4 times 10 squared, and then you take the square root of that, and then you get your answer, which is 0.3 meters. For number 47 here, we got to find the charge. We're given the force. We know what the K is. The K is always the same. So I'm just going to leave the charges as Q's here because we don't know what they are. But we know they're the same, so I can put Q for each one. Because they're the same charge, I can use the same variable. So we're going to cross multiply here again. Let me show you how I do that. Multiply the top times the denominator of the second one and set that equal to the other side. I'm just going to go ahead and put Q squared now because it's Q times Q. Let me explain how I did that. I divided both sides by 9 times 10 to the 9th, and then I took the square root. So this is really stuff that we're comfortable doing. We're just not comfortable doing it with numbers this big, or this small, rather. I want to remind you what a microcoulomb is. It's just times 10 to the negative 6th. So if you have 3 microcoulombs.
Allison Griffin, please report to the main office. Allison Griffin to the main office.
I'm just showing you here exactly what a microcoulomb is. You just add a times 10 to the negative 6 to put it into coulombs. That's all you do. So anyway, we're given 3 different charges here, and we got to find the force, the net force on the middle charge. Well, in order to find the net force, you got to find the sum of the forces. So let's go ahead and find the force between the first two. I just put the numbers into my equation. The force between the second two, we just type in those numbers into that equation. The only difference is going to be your charges and your radius, which is all given. Alright, so you plug that into your calculator, be very careful. And I'm going to start a new page here where I'll just go ahead and fill in the values that I got after I put that into my calculator. I got 21.6 newtons on that side, I got 120 newtons on that side. Well, what does that mean? If we take a look at your charges up top, they're both going to be attracting. So, which side is going to pull it more? Well, it's going to pull more to the right because it's a bigger charge. How much more to the right? You got to do your subtraction. 120 minus 21.6 to get the net charge, which is 98.4 newtons. So, again, take a look at who's pulling who in which direction. In this case, the center guy is being pulled both to the left and to the right. He's being pulled to the right more. How much more? You got to do your subtraction, and that's your answer. Number 49, we have 2 charges here. We call them Q and 3Q. We don't know what they are, but we can still set up our equation because we know everything else. We know the force, we know the K, we know the R. So we can plug everything in. We just leave the Q's as Q and 3Q. And then we cross multiply. Go ahead and multiply your Q and 3Q together, comes out to 3Q squared. I'll show you how I did this division. Divide both sides by 9 times 10 to the 9th. Then divide by 3, take the square root, and you find your value of Q. So that's half the answer. You also got to find the value of 3Q. So I just multiply it by 3, that's it. And there's your final answer. You got to think back to chemistry for this one. We're given the mass of the coin, and we're given the molar mass of the coin. Oh my god, I forgot molar mass. It's just grams per mole. Usually you have to calculate it. In this problem I give it to you because it's not chemistry class. So we're going to convert from grams to moles using the handy conversion factor that's given to us. What you want goes on the top, what you want to get rid of goes on the bottom, so you can cross it out. So now we've converted to moles. Now we've got to convert from moles to atoms. What you want goes on the top, what you want to get rid of goes on the bottom. So we can cross out our moles. Now we have atoms. Alright, so now we're halfway there. We have atoms. Now we got to find the number of electrons. So we have another conversion factor. It's given to us in the problem. They say that in one atom there are this many electrons, 28.75. So we cross out. Now we have electrons. We're still not done. We've got to find coulombs. So I know how many coulombs are in an electron. If you forget, it's in the textbook, it's on Google. Do what you got to do. It's just a standard conversion factor. So now we have coulombs. So go back and look at it. Make sure you're comfortable with everything that just happened. All we're doing is dimensional analysis. We're not actually using our brains. We're just plugging in the conversion factors that are given to us to get the units that we want. Okay, 51. We have 3 particles again, given to us in microcoulombs, so don't forget to do your times 10 to the negative 6. We're also given centimeters. Be careful, we need meters. Let's go ahead and find the force between purple and red here. Notice how I converted to coulombs by adding a times 10 to the negative 6. Notice how I converted to meters there at the bottom. And you got your force. Same thing over here. Notice how I convert to coulombs by adding a 10 to the negative 6. I ran out of room here. And then on the bottom again, notice how I convert to meters to find this force. So who's going to win? We got 60 pulling that way. We got 43 pulling that way. Well, the prevailing force is going to be to the right because 60 is bigger than 43. How much bigger? 18. All right. Part B, we got to find the force on a different particle. This time it's the right particle. Well, I already know what the force is between the right one and the middle one. I just figured that out. It's 60.9. Now I got to figure out the force between the right one and the left one. So I got to set up a new equation. We put in our 2 charges. We put in our radius, which is given in the problem. You just got to do 72 centimeters times 2. So now I've found the new force. So if I have 18.6 pulling it to the right, or pushing it to the right rather, and I have 60.9 pulling it to the left, who's going to win? What's going to be the prevailing force? Well, the force to the left is bigger because 60.9 is bigger than 18.6. How much bigger? You got to take the difference between the two. 49 newtons to the left. If you're unsure how I got those directions, take a look at your charges. It looks like I forgot to write them in. Let me write them in right now. We have a negative charge above the purple. Above the red is a positive charge. Above the pink is a negative charge. So you can see 2 negatives repel. That's why this arrow here is going to the right. It's pushing it away. The opposite charges attract. That's why I drew the arrow to the left here. It's pulling it towards itself. The red one is pulling it towards him. So that's how I got those directions. And then you just take the difference, and that's going to be the total force. All right. I hope that this was helpful.